This is a lesson on graphing a cosine function. So the form of our function would be y equals a cosine bx plus c. And some relevant formulas here are that the value of a would be the amplitude, and we could obtain the period of this wave by dividing 2 pi by the value of b. And the phase shift, I'm going to abbreviate that PS, so phase shift is minus c over b. Okay, so for our first example, let's look at y equals 3 cosine pi x plus pi over 4. So we could determine the amplitude, the period, and the phase shift using these three formulas. In this case, the amplitude would be 3, and our period would be 2 pi divided by b. Here b is pi, and c is pi over 4. Okay, so getting back to the formulas, our amplitude is 3, the period would be 2 pi divided by b, which is pi, so that would be 2. And the phase shift is minus c over b. In this case, c is pi over 4, so we'd have minus pi over 4 divided by b, which is pi. So negative 1/4. So that all works fine, and that'll give us the information we need to make the graph. Another way we can get all of that information through just a little bit of algebra, and in this case you don't need to remember any formulas. What you can do is take the bx plus c, in this case pi x plus pi over 4, and trap that between 0 and 2 pi. The reason for 0 and 2 pi is that that is the standard fundamental interval for the sine and cosine functions without any adjustments. So here we're going to now solve for x. So the first thing I would do in solving for x would be to subtract pi over 4 from all three expressions. 2 pi minus pi over 4. Let's see, 2 pi would be 8 pi over 4 minus 1 pi over 4 would be 7 pi over 4. And 0 minus pi over 4 is negative pi over 4. And we're solving for x, so the next step would be to divide by pi. And dividing through by pi gives us x is lesser than or equal to 7/4 and greater than or equal to negative 1/4. And that's it. So this gives us the interval for which we want to make this graph. The phase shift is given by the starting point would be negative 1/4. And notice that's exactly what we got up here when we used the formula. And the period would be the length of this interval, the length of the interval from minus 1/4 to 7/4. One way to get that is to subtract the endpoint. So we'd have 7/4 minus minus 1/4 would be 7/4 plus 1/4, or 2. So in either case, when using the formulas or using the method of solving for x in the compound inequalities, we get the same information. Now let's go up and make the graph. Our phase shift is negative 1/4. I could use negative 1/4 is 1 square is equal to 1/4, but I feel like that might make the graph a little tight. Let's see, we have 1, 2, 3, 4, 5, 6, 7 quarters to the right. Maybe that won't be too bad. If we tried to use 2 boxes, then I think we're going to be off the graph. So we will go ahead and let one box equal 1/4. Now we want to divide this into 4 pieces, equal pieces. And since our period is 2, the 4 equal pieces we would get would be divide the period, when we divide the period by 4. So dividing that by 4, 2 divided by 4 equals 1/2. And that gives us our spacing between the tick marks, the important tick marks we want to make when graphing a sine or cosine. So our initial starting point, as we figured out already, is negative pi over 4. Our ending point is at 7/4, so 1, 2, 3, 1, 2, 3, 4, 5, 6, 7 is right here. 7/4. And the spacing should be 1/2 or 2/4 between. So we're going to want to mark off every 2/4. So 1, 2, 1, 2, 1, 2. And this gives us 4 equally spaced subintervals there. Okay, we're almost there. We want to make the graph. The amplitude is 3, and we'll go ahead and just let each box be of unit length. So 3 is there, and then the lower part of our graph will be down here at -3. We start the cosine. We should have our original form in mind for the cosine function. Normally, cosine would start at up here at 1 on the y-axis at x equals 0, and then complete one period at 2 pi. And this is just for the standard y equals cosine x. So our 3 multiplier, that stretches the graph vertically to give it an amplitude of 3. And then the pi x plus pi over 4 on the inside here shifts our graph and also stretches it horizontally. And we found out all the information now we need to make that picture. Okay, so we start at the top, just as we see over here in our normal cosine function. And then the next dot we'll draw would be at the next tick mark that we indicated earlier, it's 1/4. And then it'll reach its lowest point, the next important point, back to equilibrium, and then back to original height of 3. So it's important to draw those 5 dots in first. It makes it easier to draw the graph. And then make sure your graph is nice and rounded. Don't use a corner or cusp there. You want a nice smooth graph. And then I'll usually put some dashed lines to indicate this is just a part of the graph that repeats. Okay, so that was y equals 3 cosine pi x plus pi over 4. We could check that with the graphing calculator. The interval gives us our x min, our x max. The amplitude gives us our y min, y max. We had, by the way, we noticed there was no plus d, which would be our vertical shift. Had we had a vertical shift, that would just lift or lower this shape that we had drawn. And we'll look at one of those as a final example in the next video lesson. Hope this helps. Thanks for watching.